Hey, don't say mean things about Rodelia or Sevilla or Ronaldo or Crystal. There's one more person you've been talking smack about, but I can't remember who it is. Who was the other person that you were being so mean about a minute ago? All right, we won't repeat that stuff, though, because it's way too mean. All right, so for today, we are going to dig into just a couple of those quadrilaterals, some of those nice ones. Now, because you guys have shown me that you know what all these shapes are, I'm going to present this very differently than I did third hour, so I don't just bore you with just talking about these things, because you've shown me that you know what they are. Okay, as we're going through, we're going to start right now 6.2, and our focus is only going to be on two of those quadrilaterals that we saw. Instead of writing it right here, because we're going to see them both, I'm just going to make my first section be the name of both of them. Bless you.
Thank you.
And we'll just make one section be one of them and one section be the other. So the first thing that we're going to look at is we're going to look about kites first. We're going to look at the oddballs out. Instead of rectangles and squares and those stuff, we're going to start with kites as our first focus. Now, when you think of a kite, the one that I had on the board a moment ago, it was an annoying one because it's not the way that it normally looks. When we look at a kite, we are going to have two, and we'll just define it real quick, two sets of congruent sides. And I'm even going to put a little follow-up. These congruent sides, they have to be adjacent. Add, what? Oh, okay, I misunderstood. They have to be the adjacent sides. Now, it turns out there are a lot of extra properties of these things that you may know just from memory, but if you don't, we're going to dig into them. So we have a foregone, and we can specify, I'll just say foregons, that's our focus. We'll probably have another section that's called foregons. We have two sets of congruent sides, and they have to be adjacent to each other. This one right here? Yeah. Adjacent. A-D-J-A-C-E-N-T. Now, what on earth does adjacent mean? Yep, they're neighbors. They're beside each other. So if you have adjacent sides, they should share a vertex. That's what that really means. So if we were to just draw one, and I'm going to draw it sideways here, and it might not be perfectly to scale, but I'm going to draw it big enough that I can add a few extra lines in here. And it's not going to be to scale at all, but that looks believable. Okay, this, I'm going to start with K, I, T, and E. So here's a wonderful kite that we have on this thing. Now, there are a ton of extra properties that we're going to get out. I'm going to fix it because it's not quite a kite there, right? Can you guys tell that it's off? It's really bugging me, so I'm going to fix it. You don't have to change yours, but it bothers me. We're going to fix this. I don't know why I wouldn't do it just as I have graph paper. What do we do? All right, so here's my new kite that's nice and to scale. You do not have to change yours, and that was K, right?
Yeah.
I and T and E. Now, yours doesn't have to be gigantic like this. I just want to make sure that everybody can see it. We are going to add in some new segments in here, and I think there's some natural segments that one might add. Heading. If I said, add me a support to this kite, like we're going to apply it, what segment would you put a support at? I, E. I agree. Okay. What we have just drawn is one of our two new special segments that I'm sure you've heard of before, but we haven't used it. I have just connected two vertices that are not next to each other, right? Can I do it anywhere else on this? I can do it to KT or TK as well. These orange segments that I've just drawn, it's weird because of the way that I've drawn, but it's intentional. These have a special name. These are called the diagonals. So if we need to have that, I know it's weird because one's vertical and horizontal, but these orange segments, if we need to define them, we have two diagonals. And we're just going to make some additional comments about these. So kites, there's two sets of congruent sides. And additionally, if we want, we can draw two diagonals. Now, do you want a formal definition for diagonal here, or are we okay with just saying they're the lines connecting vertex? Okay, so we have two diagonals here. And here's my immediate question. on this, we're going to get some more properties out of this guy. I haven't yet marked anything as being congruent. I know that they have to be adjacent to each other. What sides do you think I could mark congruent here, Chelsea?
What side?
Mm-hmm. I'll even start. What side is congruent to IT?
Wait, what's this congruent mean again? Like,
Same length.
TE.
TE. Everybody agree with that? There's one pair, and are they neighboring?
Yeah.
Yeah, they're adjacent. My other ones, I don't think it's a huge stretch. Kilo Echo, KE, and Kilo India, KI. Those are my pairs of congruent sides. Two sets of them. Notice if they were all four congruent, we wouldn't have a kite anymore. We have to have exactly two sets of congruent to each other. Now, with these diagonals, instead of just looking at one big foregon, I created a bunch of what inside of here? There's triangles everywhere in this thing. Now, our job right now is we're going to try to make sense of some of these. You do not have to sketch everything that I do, just so you know. I'm going to be erasing and redrawing bits and pieces of this. You don't have to have like 10 kites on your picture, okay? We're just going to see if we can't get the observations out. So we're going to make some more notes. Let's just look at how these diagonals change the shape and the interactions within. So for now, let's just say that you don't have to erase yours, but I'm going to erase this one. When I erase that other diagonal, I have how many triangles here? Can you tell me anything nice about those two triangles, KIT and KET? What? Not CCC. So you're trying to give me CPCCC? You can't say that they're congruent because they're congruent parts, because side will do it. Well, hold on. I only have two sides marked. Oh, you guys. KT is congruent to itself, right? So I'm just going to note that that is congruent to itself. And in this picture specifically, we can see that triangle KIT is congruent to which other triangle again? KIT. How did you know it had to be KET?
Order.
The order. What do you mean by that? Yeah, if we go KIT, I go across 2 dash and then 1 dash. To do that on this triangle, I have to go K to E and then E to T. All right, and remind me one more time, because I didn't mark my picture everywhere. Why? Side, side, side. All right, Sonny, it is your time to shine right now. I think I now know something about these angles. Okay, let me rephrase that. What do I know about these two angles?
They're congruent.
Why?
You have them dashed right there.
Tell me this thing you said.
CPCTC.
Corresponding parts of congruent triangles are congruent. Do you guys agree that this angle I and this angle E have to be the same? Now, if I wanted a way to talk about that in general, and I know I can see it on this one, we're going to write that statement, angle I is congruent. Now, all we're doing right now is we're just making some observations. There's no real end other than let's just see a bunch of stuff about these. Angle I is congruent to angle E. And I know that because Sonny says corresponding parts of congruent polygons now are congruent. CPC, PC, because it's no longer trying. No, I'm fine. I lied right to your faces. I'm sorry. Okay. Now, if I wanted a way, is that going to happen on every single kite that I ever draw?
No.
You say no, but let's try to just counter it. I'm going to draw a goofy kite real quick. You do not have to draw it. This is an awful kite. And it looks so silly. Kind of looks like a diamond if you think about a three-dimensional diamond. If I draw this, do we still get congruent triangles?
Yes.
And are these angles still going to be congruent? So in general, instead of just saying it's angle I and E, how would you describe which angles are actually congruent here? What do you mean the adjacent?
One right by side each other.
Well, but these are right by each other too. Like, are they really right next to each
They're
other?
across from each other, right?
But these are across from each other. I don't think those are the same.
No. Across from each other isn't congruent. You gotta be side by side.
Well, but these aren't side by side.
No,
And
that's
these
a
are
cross
congruent.
though. That's a cross though.
So let me rephrase this rather than just picking on Sunny here. Find me a way to describe for any kite that you ever give me, how do we generalize that it's these angles that are the same? Where do those angles live is my advice for you. I'm going to give you like 30 seconds, see if you guys can formulate it together. How do we talk about it? And I'll even draw that ugly one here. I'll pause it. What do you think we could write here?
I think it's the angle between two or the non-congruent sides.
Love it. No matter what kite we draw, this is the angle that gets formed between the sides that are not congruent, right? Every single time. It's always going to happen. So as an extension of this, as a more generalized rule, we'll say the angle, or the angles rather, formed by non-congruent sides are congruent. It will always, always, always be the case. Every single time. Okay. As we keep kicking through. Third hour, when we presented it, we came up with the short and the long diagonal, but maybe that won't always work. Maybe it will. It's okay if we have different language. We're just getting this idea cleaned up. Any other observations we can make with just this diagonal? If there's nothing that stands out, we'll move on for now, and I'm fine with that. What if we look at the other diagonal? Is there anything super meaningful? And I'm just going to erase this and add the other one back in. Control Y, are congruent. Okay, if I add this diagonal back in, and I get rid of the other one, I get two triangles again, right? Are these triangles congruent? Definitely not. Huh. Anything special about them? They are both kind of special triangles. They're both isosceles triangles, which means what? Two sides. Anything else? I also know that on each of these triangles, and I might not write it down, but I know that angle TIE, this guy, and this angle are the same, right? They're the base angles. They have to be the same. Same thing is going to happen here, but I don't know that I get anything super meaningful out of it. You guys agree with that statement? We're going to go one step further. If I add in the other diagonal all of a sudden, it looks, and notice I'm not saying it is, I'm just saying it looks like this is a what angle? Anybody feel confident that that's a right angle? Okay, I like this approach. I want to give you guys 2 minutes. Convince me of that. Cool, 2 minutes. If you think this is a right angle, I like that idea, but I don't like thinking it just because I think it is. I like thinking it because this and this and this. Why do you think this is a right angle other than it looks like it? Talk it out. 2 minutes. Right from that. And I probably should have recorded some of that. Welcome back, Rodelia, by the way. Grace, make it out? Cool. Is she going to MEPS? It's none of my business. You don't have to tell me that if not.
Wait, did you ask she's going to MEPS?
MEPS.
What's that?
It's her, MEPS is the health screening to go into the Air Force?
Yeah.
Okay, cool. Awesome. Sweet. So here we go. We get theorem. And I believe this is the third theorem of this section or chapter already. But we're just going to call this the kite theorem. Now, THM is my shorthand for theorem. And I do want to remind you guys that we had a few observations up here that are still going to be true. These other parts, these are just observations. We're going to write that very last one here as a theorem. What we just found is that one diagonal does what to the other? How? More than just angle bisector. One diagonal, it not only bisects the other, but it does so at what angle? Is the perpendicular bisector. And remember, upside down capital T means what? And just to make sure that we're not just like parroting sounds, what does it mean to be perpendicular? 90-degree angle is really the only part we care about. So one diagonal is the perpendicular bisector. And bisect means to do what? Cut in half of the other. Okay. We could pivot right now to just doing a few problems about kites. Klein, do you agree with that? Are you sure? Should Klein agree with that statement? Oh, now you're not sure. Are you really not sure? No. That's a good answer because I don't even know what to make of it. Okay. looking at this, rather than just doing a few examples with kites right now, I'm going to make a proposition. Let's talk about one more shape for a couple minutes, and then at the start of class tomorrow, we'll just do a bunch of problems that deal with both shapes. We have to be able to parse that information and separate them. Which, if you didn't notice it, it means I'm not going to do what tonight?
Homework.
Yeah, sorry guys. Okay, so we have talked about kites, and we talked a lot more than we wrote, but there's one more shape that I want to look at today, and we're going to talk our second little section about trapezoids. I cannot see this word without thinking of Futurama, which is just a fun little glimpse back into my mind again. What's a trapezoid?
Or one to parallel line.
There's exactly one pair of opposite sides parallel to each other. So we'll just say a trapezoid is simply a fourgon with, and we're really going to specify that exactly, one pair of opposite sides. And what's the shorthand for parallel again? The two lines. So I'm going to write out the word here just because it's nice to do every once in a while. In the book, remember, they do it vertically, but it looks like my 11, so I don't do it like that. Is that spelled right?
Yeah.
It looks wrong for some reason. All right. Now, for these, there are special trapezoids that everybody wants to draw. We're going to draw an ugly one first, and then we'll just compare it with the nice one that everybody wants. If all I require is two sides parallel, or yeah, one pair of sides or two sides, however you want to word it, I could say that this thing right here will form a trapezoid, as long as these are parallel. Now, this is not the trapezoid that you guys want to deal with, and I get that. That's okay. You like the trapezoid that looks nice. And specifically, when we say it looks nice, two of the sides are the same. That's what you want to be true of it, right? Have you ever seen a shape like, I don't know, a triangle, where two of the sides are the same? And what do you call that triangle? You were calling it an isosceles triangle. We have trapezoids, and we have isosceles trapezoids. We get some really nice relationships from the isosceles, but I do want to make sure that we're all aware we do have ugly trapezoids as well. They're not all the nice, beautiful isosceles ones. Do we need a really quick brain break that's going to get you guys back in the game real quick with 4 minutes left?
Yes.
Okay. Now I can tell that you're tired of the math, and don't worry, because rather than just building your mathematical minds, I'm also going to build your vocabulary, because I bought a word of the day calendar. So buckle up, everybody. Our vocab is going to increase.